Hello, grade teens. I will be starting a new chapter today. This is just an introduction. We've seen this timeline or science timeline or numbers line before. I just want to go through each name. The first one is picometers, then we have nanometers, then we have micrometers, then we have millimeters, then the normal meter. Then we have kilometers, then mega, then giga, and then the last one is terameters. Okay, so each jump between each one is 1,000. So 10 to the power 3, and it depends. If you go from a bigger one to a smaller one, so if you go in this direction, then you multiply by 1,000, and if you go from a smaller one to a bigger one, so if you're going in this direction, then you divide by 1,000. Okay, right. Then each small jump here is 10, and again it depends. If you go from a smaller one to a bigger one, then you divide by 10. If you go from a bigger one to a smaller one, you multiply by 10. Okay, here we have again milli, then we have centimeters, and then we have decimeters, and then again just a meter. So I'm just going over this again because you need to know this very well for this chapter. We're going to use meters a lot and we're going to convert a lot. Okay, right. Now you will receive notes. Can't remember if I have handed out notes before, but yeah, so no, I'm going to hand out, the teacher will hand out notes now. So I want you to just highlight with me today. So we have something called scalar and a vector. Scalar, and a vector. Now a scalar is something that has it's a physical quantity like mass or time or something like that, that only has size. So size only. Okay, where a vector is a physical quantity that has size and direction. Okay, now I'm going to explain in a moment so that you completely understand the difference. But for now, the only thing you need to know is that a scalar has size only and a vector has size and direction. Now, examples of a scalar is something like distance, speed, time, volume, mass, energy, work, power, and temperature. Okay, now work and power is two concepts that we only work with in grade 11, but the rest of the concepts you should have heard before or we will discuss in this chapter. An example of a scalar is displacement, velocity, acceleration, weight, force, and momentum. Now, momentum again is a grade 12 concept that we will discuss then. Now, if you look at distance we measure in meters. And displacement, we also measure in meters. Okay, so it seems like the two things are the same. Distance, you say I walk 10 kilometers. Displacement, you say I'm displaced 10 meters or 10 kilometers. So what is the difference between the two? Okay, and that is what I quickly want to look at just now. If we say, right, here you are, and here is the school. Okay, this is your house. This is the school, and you must walk to school. You can't just walk like that to school, right? Because there are paths and roads. Let's say you must walk like this, then you must go up, then you're going to go like that again, then you must go around something, and then you get to school. Okay, so this is the path to school. If you calculate how far you've walked, let's say this was 1 kilometer, this was 0.5 kilometers, this is 1 kilometer, this is 2, this is 1, and this is, let's say, again 0.5. Then you'll say the distance that I've walked to school, so the distance that I've walked to school is 1 plus 0.5 plus 1 plus 2 plus 1 plus 0.5, and that gives you 1, 2, 3, 4, 6 kilometers. Yeah, that's far. Right? Now, that is the distance that you walk to school. Your displacement is the direct line from your house to the school. Okay, so the displacement displacement is the direct line from your house to the school. And if we add that together, I'm just going to make this, let's say, 3 kilometers. Oh, sorry. No, man. Okay, so you can see the distance is the actual path that your feet have walked all together, and your displacement is the straight line there. But we can't just say it's 3 kilometers. Displacement must have a direction as well. So you're going to say 3 kilometers to the, let's say, to the right-ish, because you're going to go up and to the right. But we're going to look at directions in a moment. So you're going to say 3 kilometers to the right. So that is the difference between distance is just the path that you've walked, and displacement is a direct line with a direction. Okay, so that's the difference between a scalar and a vector. A scalar has only size, like distance, and the vector, like displacement, has size and direction. Okay, right. If we look at another two concepts, the one is mass and the other one is weight. Now, they seem the same, but they're not. Mass is a scalar, obviously it's with him, that is a quantity that consists, is the quantity of matter something consists of, and it's measured in kilograms. So that is how many molecules you consist of. Where weight of an object is the size of the gravitational force towards the center of the earth on it. Okay, so if you are on the earth, and you are standing here, then your mass will be, let's say you weigh 60 kilograms. Okay, then your weight, that's your mass, and your weight will be 60 times 9.8. Now that 9.8 is the force of the earth on you. Okay, not completely, but for now I'm going to say that it's actually the acceleration, but we will get to the concept of acceleration a bit later on in this chapter. Right, so if we calculate that, sorry, times 60 times 9.8, you get 588 newtons. So you can see mass in kilograms and weight in newtons are very much different. The mass, the 60 kilograms, is how many particles you consist of, and the weight is how strong the earth pulls you down. So your weight is actually downwards. That is the direction, because it is a scalar. Because it's a vector, it must have size and direction. If you are on the moon, okay, then we all know that you will actually be floating in air. Now, when you go to the moon, you're on the earth and you go to the moon, you hopefully don't lose an arm or a leg or something. So the number of molecules or particles you consist of stays the same. If you weigh 60 kilograms on earth, you will weigh 60 kilograms on the moon. But your weight will be different. Now, your weight will not be, you won't multiply with 9.8 anymore, because that is the Earth's gravitational acceleration. The moon's gravitational acceleration is much less. Much less. The moon's one is more or less 1.63 meters per second. So if you multiply that by 60, your weight will be 98 newtons. Okay, again towards the downwards. Okay, why must it be a direction? Because it is a vector. It has size and direction. So you can see your weight, your mass always stays constant, but your weight changed because it is directly proportional. It depends on what the force of the earth or the moon or whatever is on you. So here it says here the mass is your kilograms. It's how many particles you consist of, where your weight is the size of the gravitational force. How strong does the force pull you down? And that's measured in newtons. Now, what is a force? A A force is a push or a pull that can deform an object. It can change the shape of it, or it changes its state of motion. Our state of motion means it makes it move or causes it to stop. Okay, now the next concept we're going to look at is frame of reference. Okay, so sorry, what is a frame of reference? The definition there, it has an origin and it has a set of directions. Now I'm going to explain this part here at the bottom in a moment. So let's say this is South Africa. I'm going to try to draw South Africa now, but it won't be good. There we go. Something like that. Okay, right. Now here we have Cape Town. And there we have Johannesburg. Right. Now, you are here in the Free State, in Parys. There you are. And you are calling your friend in Cape Town. Or your friend in Cape Town is calling you. They say, hey, what's up? You are close to Johannesburg. Tell me, how far is Johannesburg? And you tell that person, oh, Johannesburg is only like 150 kilometers. Now this person get in their car and they drive 150 kilometers. Will they get to Johannesburg? No, they will only be here. Okay, you guys had a misunderstanding. You thought this person in Cape Town said, how far is Johannesburg from them? And you thought he asked, how far is it from you? That is a massive difference, 150 and 150. Okay, so you must have a frame of reference. You must say, okay, no, Johannesburg, where is my notes now? Johannesburg is 150 kilometers from Parys. But Johannesburg is 1,400 kilometers from Cape Town. Okay, so the person said, yes, thank you. And now they're driving their car and they drive 1,400 kilometers in that direction. Will they get to Johannesburg? No, they must drive in this direction. So you can't just say from where, you must also say in what direction they must drive. You must say, okay, it is 1,400 kilometers from Cape Town, driving. Now, I don't know if you all know this, but there is north, east, south, west. I really hope you know that. So you're going to tell the person, oh, you're going to drive northeast. So it's 1,400 kilometers driving in the northeasterly direction. Okay, so frame of reference means you say from where we are looking and in what direction. Okay, right, so that is what I say here more or less. I just didn't give a direction. So you must have an origin where you start from. So origin means your starting position, and set of directions. You must say, is it in north, east, south, or west direction? Okay, so grade 10s, I just want to check that I don't want to give you any homework just yet. Maybe. I do want to give you some homework, but only one question. I want you to please do question 6 on page 6. Question 6 on page 6. And I want you to do that. And you must look here at the scalars and vectors to help you answer that question.